Math 1, function evaluation. So, format here is you're going to be working on some, and then watch some of the video to see how you did. You can find your mistakes, fix them. So, in between, I'll do an example for each section, and then the guest teacher will need to pause the video so that you have time to work on those. Please work on those and get them done and try them on your own, and then watch to see how well you did. Okay, so we'll start by taking an example of number 1. Now remember, when we're dealing with function notation, okay, that H or F or G or F or W, okay, that's the name of the function. Okay, it's not a variable, it's the name of the function. The variable inside, whether it's X, T, N, or anything else, okay, that's your input. You also notice it right here, right? H of X together indicates the output. Okay, the X, or the variable, that's our input. Okay, that gives us the two groups. It's equal to the pattern. That pattern is going to give us the, what the function is. And then when we start to actually evaluate for certain ones, that's when we'll find if it's 1-to-1. Okay, so the way you do this is we are going to take that -1 and we're going to replace all our variables with -1 in this case. Okay, now on the left side, I don't need to deal with this guy anymore. Okay, so if you want to, you can just bring it down to be part of your answer. Okay, so then I only deal with that part of the function that's not the output, that's not the name. Okay, we only deal with this to evaluate. So 2 times -1 is -2. -2 plus 3 is a +1. So my result is a +1. So what this tells me, h of -1 equals 1, tells me that with an input, an x value of -1, my output, my y value is 1. So if I'm making a table, that's -1, 1. If I'm graphing it, -1, +1. Okay. If I'm writing it as a coordinate, -1, 1. That's what that means. So you need that written like that, not just that answer there. You need the whole thing in the box. Okay. So what you need to do now is take some time and do up to problems number 10. Now, if you feel like you can go on, by all means go on if you have the time. But your guest teacher will tell you how long to give for these first 10, about 10 to 15 minutes, but then go from there. So you can pause the video now. Alright, so now let's take a look at how you did. So hopefully you were able to get them all done. You should have had enough time to do that. So let's just kind of knock these out. So an input of 2, so I go f of 2 equals 3 times 2 minus 5. Okay, 3 times 2 is 6. 6 minus 5 is also 1. So I get f of 2 equals 1. And that's my answer. So an input of 2 gives me an output of 1. Alright, number 3. Now we've got -5 here. So I go f of -5, and I get negative, and then I put the -5 in there, so you have to pay attention to that, plus 2. Negative is a positive. 5 plus 2 gives me 7. So f of -5 equals 7. And there's my answer there. Okay, number 4, I have g, function g, and I want to find for an input of 6. So I replace my x's with 6's. So I get 2 times 6, which is 12, minus 1, gives me 11. So g of 6 gives me an 11. Input of 6, output of 11. Okay, now f of -7, because that's the input I want to put in. 4 times -7. 4 times -7 is -28. So f of -7 equals -28. Input of -7, output of -28. Hopefully you're seeing the pattern here. Now g of -7 for this other function, g. So -7 in for x, plus 3. -7 plus 3 is not -10. It'd actually be -4. So g of -7 equals -4. X value of -7, y value of -4. Input of -7, output of negative 4. All right, 7. H of n equals 4n plus 3. So 0 in, so h of 0 equals 4 times 0 plus 3. 4 times 0 is 0. 0 plus 3 is 3. Notice that I'm not touching this left side, okay, because I don't need to. It's not part of our evaluation, okay? So, independent variable of 0, dependent variable of 3. Number 8, so 6 for our input. So W of 6 equals 4 times 6 plus 3. 4 times 6 is 24, plus 3 gives us 27. So, input of 6, output of 27. Okay, f of 3 now equals 4 times 3 minus 5. 4 times 3 is 12, minus 5 is 7. F of 3 equals 7. And then finally for 10, 8 for our input. So 2 times 8 plus 4 equals W of 8. So we get 16 plus 4, which is 20. So that's how we deal with those ones. Okay. All right. Now the next ones. Okay. Now notice here we've dealt with linear, right? Because they were all multiplication. Now we're dealing with some exponential because it's got the power. Okay. So, but we treat it the same way. So let's take a look at number 11. So, input of negative 1. So I go P of negative 1 equals 5 to the 2 times negative 1 plus 2. Now, according to order of operation, we need to deal with this exponent first. So first we simplify the top number, then apply the exponent, then we add the 2. And you may need to use your calculator on these ones. So 2 times negative 1 is negative 2. So I have 5 to the negative 2 power. Okay. So then 5 to the negative 2 gives us, and you'll definitely want to use your calculator here, and that gives us 1 over 25. Or, if we wanted the decimal version, it would give us about 0.04. Either one I'll accept. Then we add 2 to it, so we can get 2.04. Or if we added 2, that would be like 50 over 25. So it would be 51/25. Or 2 and 1/25. Either one of those, 3 I'll accept, equals P of negative 1. Okay? So just treat them the same way. Make sure you use the calculator to help you with those exponents. And pause the video now for about another 10 minutes, 10 to 15. And let's go to question number 20 now. Okay? So right here. All right, get to work. Pause the video. All right, so here we go. Taking a look at these now. We will start with, we already started with 11, so 12. So I take my input into the x, and I go h of negative 1 equals 4 to the negative 1 plus 3. Negative 1 plus 3, since it's all in the power, we start with that first. That would be 2, so I'd get 4 squared. So 4 squared is 4 times 4, so it's 16. So h of negative 1 equals 16. Input of negative 1, output of 16. 13. Okay, I've got 1, so I go f of 1 equals 2 to the 2 times 1 minus 3. So 2 times 1 is 2. So 2 squared minus 3. 2 squared is 4. 4 minus 3 is 1. So f of 1 equals 1. Independent value of 1. Dependent value of 1. Okay. Number 14, P of 0. So P of 0 equals negative 4 to the 3 times 0. 3 times 0 is 0. Now, you may think the answer of this to this is 0, but actually there's a rule with exponents that anything to the 0 power is 1. So P of 0 would equal 1. All right, number 15. So we've got g of negative 2 equals 3 to the negative 2. Okay, so whenever you have a power that's a negative, it actually makes a fraction like that. I mean, you can type it into the calculator, and you'll get, if you want the, oh, that's a 2, not a 3. 3 squared is 9. You'll get 1 over 9. And if you want it as a decimal in the calculator, that would be 0.1 repeated. So 1 over 9, or 0.1 repeated, is g of negative 2. Okay? And finally, number 16 on this page, we have w of 1 equals negative 4 to the first. Anything to the first power is just itself, so w of 1 equals negative 4. Since we're going to 20, we'll jump onto the other page. So I go h of negative 2 equals 5 to the negative 2 plus 1 plus 2. So negative 2 to the plus 1 is 5 to the negative 1 plus 2. That becomes 1/5, or 0.2 if you prefer the decimal. And we add 2 to that. So I get 2.2, or 2 1/5, or even. So h of negative 2 equals either one of these versions. I'll accept. Okay, 18, negative 2 of our input, so k of negative 2 equals negative 3 times 3 to the negative 2. So we get negative 3 times 3 to the negative 2 would be 1 over 3 squared, or 1 over 9, which is probably easier to deal with than the 0.1s. So negative 3 times 1 over 9, that would be like negative 3 over 9, which reduces to negative 1/3, or 0.3. So that is k to the negative 2. Now, some of these answers are a little tricky to deal with, but they still work the same way. Okay, 19 and 20. So f of, actually, let me scoot that up. F of 0 equals negative 3 times 3 to the 2 times 0 minus 1. 2 times 0 would be 0. 0 minus 1 would be negative 1. 3 to the negative 1 would be 1 over 3. Negative 3 times 1 over 3 would be negative 1. So f of 0 equals negative 1. Input of 0, output of negative 1. And finally 20, let's do it up here. H of 0 equals 4 times 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. 4 to the first is just 4. So h of 0 equals 4. Okay, so that's the next group. Now we're going to go from 21 to 26. Okay, I'm not going to give you an example on these ones. Just notice if it has multiple variables, you put one in for each. Those bars mean absolute value, changes positive to positive and negative to positive. Okay, so take about 10 minutes, 5 to 10 minutes on this one, and see what you can do. So you should pause the video now. Alright, so let's take a look at these ones. Okay, so g of 3. So g of 3 equals 3 cubed plus 5 times 3 squared. So I deal with powers first. So 3 cubed is 3 times 3 times 3, either using your calculator or just going at a piece at a time. That's 9, 27. Plus 5 times 3 squared would be 9. 5 times 9 would be 45. 27 and 45 would be 60, 72. So input of 3, g of 3, equals output of 72. Okay. 22, we go h of 3 equals the absolute value of 2 times 3. 2 times 3 is 6. Absolute value of 6 is 6. So h of 3 equals 6. Okay, if we look at 24, k of negative 3 here equals negative 3 squared plus 1. Now here's where we run into some trouble, because in the calculator, if you type it in like this, it'll give you an answer of negative 9. But negative 3 squared is really negative 3 times negative 3, so it should be positive 9. Okay, so if you do it in the calculator, make sure you put parentheses around the negative. And then the calculator will realize that you want to square the whole thing, not just the 3. Okay, so you got to be careful of that. So negative 3 squared is 9. 9 plus 1 gives us 10. So input of negative 3, output of 10. Okay, now 23. So we've got p of 2 equals 2 squared plus 4 times 2. 2 squared is 4. 4 times 2 is 8. 4 plus 8 gives us 12. So p of 2 equals 12. Okay, now 25. So k of input of 4 equals negative 2 times 4 cubed plus 3 minus 4. So order of operations, power first. 4 cubed, 4 times 4 is 16, times 4 again is actually 64. So negative 2 times 64 plus 3 minus 4. Now multiplication, negative 2 times 64 is negative 128 plus 3 minus 4 plus 3, negative 131 minus, oops, wrong way. Don't make a silly mistake like that. Okay, would be negative 125 minus 4 should take it to 1, negative 129. So k of 4 would equal negative 129. Okay, now 26. So h of 7, that's our input, equals the absolute value of 7 minus 2 plus 2. So deal with the absolute value first. 7 minus 2 would be 5. Absolute value of 5 is 5. 5 plus 2 is 7. So h of 7 equals 7. Okay, now we've got all those ones done. So we are going to be moving on to the next one. Now, what we haven't really talked about is like number 29 and 30. When now you're given the output and you want to find what the input would be. Normally we're given the input and we want to find the output. Okay, so I'm not going to do 27 and 28 since I only have 2 examples, but I'll try a different one. So say I wanted to find f of 0 and f of 3. Okay, well an input of 0, this is that same x value, right? There's my input. So an input of 0 gives me an output, because that's what I'm looking for, of 5. Because this column is my output column. Okay, so it's as simple as that. Input of 3, output of negative 10. Now 29 and 30, they're going the opposite way. Okay, so that's like saying f of x equals negative 10. We already saw that x is 3 when the output is negative 10. This is saying I know the output, now find the input. So f of 3 equals negative 10. Okay, so you probably won't need a ton of time to do that. But before we cut you loose on that, well actually yeah, let's do that. Take a minute or two. So pause the video right now. Alright, so hopefully you, maybe 5 minutes max on that one. You shouldn't need that long. It's a pretty easy one to deal with, okay? So, f of 1 would equal, well, f of 1, that's 1, would also equal 1. Okay, 28, f of negative 2, so input of negative 2 gives me an output of 10, so that equals 10. Okay, now 29, what about when I have an output of negative 4? Output of negative 4 gives me an input of 2, so x equals 2. In other words, f of 2 equals negative 4. 30 gives me an output of 8, gives me an input of negative 1. So f of negative 1 equals 8. So the x value was negative 1. Okay. Now you can do these also when we're dealing with, sometimes you'll get this, so let me just show you a few examples. So say we look at 4. Okay, say instead the question was given f of x equals 11, okay, then what is x going to equal? So if we're doing it with an equation, and this is actually should be g of x, is that g of x equals 10. So I replace a g of x with 10, and we get 2x minus 1. Now, this is only when you're given the output, not the input, and you have to work backwards, okay? So don't mix this up. So actually was equaling 11, wasn't it, not 10? Okay, so I add 1 to both sides. So 11 plus 1 would be 12, because now I'm just solving for x. Divide by 2, and we get 6 equals x, which is kind of what our original answer was, which you probably already had. Okay, but that's a way that you can do it in those situations. Okay, so like number 10, okay, if I said w of n equals 56, what is x going to equal? Well, w of n becomes 56. Normally, we replace the input, but now I'm replacing the output and solving for the input. So I guess that's n, not x. Subtract 4. We get 52 equals 2n. Divide by 2. And we would get 26 equals n. So when x is 26, or when n is 26, w of n is 56. Okay? So just wanted to make sure that you guys understood that as well. Okay? So, alright, so now let's take a look at when we're given graphs. Okay, so these last problems are all dealing with the same thing, but first we'll just do this group of the linear graph, right? We know it's linear because it's a straight line, because for those intervals, every time I go to the right one, okay, we're going to be going up the same amount. So same, constant rate over constant interval for that linear. Alright, but we treat it the same way. Now the x here, that's our input, okay? And the y is our f of x, that's our output. Okay, so once again we have questions given the inputs. We have questions given the outputs. So the first type of question, so let's say we've got f of negative 3. Okay, so on my input, I go to negative 3. Negative 3 is right there. Now I'm going to connect it to my graph. Going down, there's my graph right there. What's my output? My output is also negative 3. Okay. It works the other way, like 35 and 36, where if I go given f of x equals, so given f of x equals 4, so I go to my y value, because that's the output of 4 is right here. Go find my graph, drop it down, and it looks like it's at 1/2, or 0.5. So x would equal 1/2. Okay? So take about 5 minutes on this one and see what you get. So pause the video now. So you should have the video paused by now. Okay, you should have done all these problems. So let's see what we got. So f of 1, so I go to x value of 1, go up to my graph, what's my y value? My y value is 5. Okay, f of 0, go to 0 for my x, go up, what's my y? Well, that's my y-intercept, so it's 3. Okay, input of 0 gives me an output of 3. Input of 1 gives me an output of 5. Now, f of negative 2, go to where x is negative 2, down to my graph. What's my y value there? It's negative 1. Okay, finally, f of negative 4, go to my x value of negative 4, down to my graph. What's my y value? It's negative 5. Alright, now when we go backwards, f of x equals negative 1, so I go to negative 1. I've already done that one, I should know that's actually x equals negative 2. Okay, that's that guy right there. Then 36, f of x equals 1. So I go up to 1, go across here, and it's at negative 1. So x equals negative 1. So f of negative 1 equals positive 1. Alright, so with that in mind, I think we should probably just give you about 10 minutes to try these last problems. Okay, so now this graph, I wrote g of x, but all these are f, so we'll just change that to f of x. Okay, now we're dealing with the exponential. So remember, exponential, we have that common interval, that same interval, but the difference now is we're dealing with the multiplication. Okay, so that constant ratio over that constant interval. So take about 5 or 10 minutes to do this one, and then we'll finish it off. So you should have paused the video right then, so if not, hurry and pause it again. Alright, so let's finish this up now. So, f of 1, so we go to the x value of 1. What's my y value? It's 4, so f of 1 equals 4. F of negative 1, I go back to negative 1 up to my graph. Looks like it's halfway between 0 and 2, so it would be positive 1. Okay, f of 0, 0 is right here. Go up to my graph hits it at 2, so f of 0 equals 2. F of 4, clear over here at 4. Go up to where my graph is. Where's my graph hitting? The y value is 32. And f of 2. F of 2 goes up, y value is 8. Alright, then the last two are just given the outputs. So the y value is what's the x value. So if we go up to 16, so 16's right here, go over to my graph hits right here at 3, so x equals 3. So f of 3 equals 16. And number 43, what if f of x equals 2? Well, 2, we've already done that one, right? We go down, it hits at 0. So x equals 0, so it's that f of 0 equals 2. Alright, so there's all that function notation. Hopefully you should have finished this, so you need to make sure that you hand these in class. If you're at home catching up, then obviously you need to bring it to class. Other than that, we are done. So if there's any time left in class, work on some missing work and be ready to go.